Hi, the SI meteorologist Paul Dorian here with a brief discussion on weather and the home run, two of my favorite topics, weather and baseball. We'll talk a little bit about the weather parameters such as temperatures, humidity, winds, and even barometric pressure as it relates to altitude and how those weather parameters can affect the flight of a baseball. Well, there have been many great home run hitters in the history of the game, and it's always been an age-old argument who has hit the longest home run in the history of the game. We have today's great home run sluggers of Ryan Howard of the Phillies and Albert Pujols. Then back in the 50s and 60s we had Mickey Mantle. In the 30s and 40s Josh Gibson was hitting titanic home runs in the Negro Leagues. And then of course in the early part of the 20th century Babe Ruth was hitting some mammoth home runs back in the 20s and 30s. Well, let's first start off with an old photograph here of Griffith Stadium in Washington, D.C., showing the trajectory of a Mickey Mantle home run that was estimated to go about 565 feet. This occurred in April of 1953. Mickey Mantle was batting right-handed and hit a ball that was reportedly the only ball that went out of Griffith Stadium and actually hit just off the scoreboard and bounced past that, went over the bleachers, and reportedly was estimated at about 565 feet. There were some strong wind gusts that day. The wind was blowing out towards left field, which aided in the movement of the ball, perhaps giving it an extra boost of 10 or 20 feet or so. But again, this was reportedly estimated at about 565 feet, one of the longest home runs in the history of the game. But here's yet another old photograph, this of Yankee Stadium, the old Yankee Stadium, and it shows the trajectory of another mammoth home run by Mickey Mantle. This time he was batting left-handed and hit the ball way up here against the facade of Yankee Stadium. This was some 118 feet above the ground level and about 370 feet from the point on the ground to home plate, one of the longest home runs ever in the history of baseball. Estimates kind of vary wildly for this particular home run, all the way past 700 feet by some people, but some physicists claim that that is impossible. It was more like 530 feet, 550 feet. Nonetheless, it was one of the longest home runs ever recorded in the history of the game. And in fact, the Guinness Book of World Records has another Mickey Mantle home run, a third one, that occurred at the old Tiger Stadium as the longest home run ever, measured at 634 feet from September of 1960. Well, we're not going to resolve who has hit the longest home run in the history of the game, but we are going to talk about some atmospheric effects that are not quite as controversial. And right here we have from a NASA website some of the forces on a baseball that contribute to the distance that a ball can travel. First of all, the lift is provided by the batter. Now there's some variables involved like the weight of the bat speed, the strength of the batter, and also the speed of the pitch coming in. All these play a role in the lift, the initial lift of the baseball. Now the weight of the baseball itself has a component towards the Earth's center. This of course will help to pull down the ball towards the center of the Earth, and the typical baseball is supposed to weigh about 5 ounces. Strictly speaking, the weight is 5/16 of a pound. Now the ball will travel through the air, and the air of course has some frictional component to it and some viscosity that has to play a role, and all these affect the drag on the baseball. And some of the atmospheric parameters that we can talk about in a moment, like temperature and humidity and winds and even altitude, play a role in the drag of the baseball. Warm air is less dense than cold air, so we know that warm air provides less of a drag for the baseball. Humid air is less dense than dry air because of the molecular weight differences between humid air and dry air. So we would tend to believe that the ball would travel more in a humid environment than a dry environment. And with respect to altitude, the higher up one goes, the less dense is the air. So the higher up one goes, the farther the ball should travel. Well, let's now try to summarize some of these effects on drag that the weather may have. And again, we mentioned that the warmer the air gets, the less dense. So it's pretty well believed by everybody that the warmer, less dense leads to less drag, and the ball can carry farther than if it was cold or cool. Humidity. Now, higher humidity amounts do contain less dense air molecules. However, it is now believed that the higher humidity actually becomes a neutral signal here in terms of how far the ball can travel, because while the air is less dense in the higher humidity air, the ball actually absorbs some moisture, and this adds very slightly to the weight of the ball, which pulls down the ball towards the center of the earth. So again, humidity is more or less a neutral factor here when it comes to the flight of a baseball. Winds blowing out is pretty widely believed that winds blowing out adds to the flight of the ball. It's very difficult to measure exactly how much because of the gustiness nature of the winds. Again, with that first Mickey Mantle home run that we talked about, the winds were blowing out, in some cases gusting up to 40 miles per hour, which undoubtedly would add 10 or 20 feet or so to the flight of a baseball. Now, altitude is one other thing to talk about here. The higher up one goes, the less dense is the air, and therefore the less drag, so the ball should carry farther in places like Colorado, for example. In fact, the Colorado Rockies broke onto the scene in the mid-90s, and from 95 to about 2001, they almost always led the league in home runs and other offensive categories such as runs scored, because it's widely believed because of the less dense, high-altitude conditions in Colorado. Come 2001, Major League Baseball decided to try to reduce that and equalize things from Colorado compared to other baseball stadiums around the country, and they decided to refrigerate the baseballs. In fact, they now put the baseballs before every home game in a humidor that cools off the baseballs, and this has worked. This has brought Colorado back to the middle of the pack, still maybe in the top half in terms of number of home runs, but closer to the middle of the pack. And the refrigeration of the balls does a couple of things. First of all, it reduces the bounciness of the balls, which would reduce the distance the ball can travel, and it tends to add a little bit of moisture. The balls absorb a little bit of moisture while they're refrigerated, and this adds to the weight of the ball. And so the bottom line is refrigeration of the balls in Colorado has definitely worked, cutting down on the number of home runs and the distance that the ball travels. By the way, the second highest altitude stadium, not too widely known, happens to be the Atlanta Stadium for the Atlanta Braves in Georgia. Now there are not too many home runs hit relative to some other stadiums because the fences are pretty far back. So the bottom line here on the best conditions for hitting a long home run: warm to hot air temperature as opposed to cool or cold, high altitude, and the winds blowing out from behind the batter towards the field in which the ball is traveling. So again, these are the best conditions for a home run, but one variable not mentioned here, of course, is the quality of the opposing pitcher. If you're facing Nolan Ryan in his heyday in 90-degree air temperature versus 70, probably not going to make a heck of a lot of difference on hitting the ball for a long distance. That's it for now. I'm the SI meteorologist, Paul Dorian.